So an induction, I'll tell you step by step. So for example, we have this question number 2a. Okay, we have one statement, square of 1 plus square of 2 plus square of 3 up to square of n equals to 1 over 3 n times n plus 1 and times n plus, right?
So can you show 2A in the PDF too?
PTA. This is the question.
Okay.
Question number 2. I'm not taking question number 1. I'm taking 2 because through this example, we'll understand what is induction and how do we use induction method to prove a statement. Okay.
Okay, sir.
So this is a statement. Listen, what is the induction method? If some statement is given, statement, I mean here mathematical statement. Whenever I'm talking here statement, I mean a mathematical statement, like you can see it's 2a. This is square of, this is what? A sum of square of natural number. Okay, sum of square of n natural number equals to 1 over 3 n times n plus 1 times n plus 1 over 2. Okay. So how do we use induction method to prove this one? First of all, what you have to do, whatever statement is given, right, that's Pn equals to prove. Okay, for now I'm going. Whatever statement is given, right, that is Pn equals to. So Pn or such that, or you can write Pn equals to, this is Pn, okay? The statement itself is a Pn. Correct? This is statement. This statement is the Pn. Now what you will do, after writing the statement, you will write P1. You will write n equals to 1. You will take the value n equals to 1. Okay? And you will write this n equals to 1 in the result. If you write, look here, if you write P equals to 1, so there should be only square of 1 here, right? This left hand side must be equals to right hand side. Let's we check it. This is 1 over 3. N means 1. Again times n plus 1 means 1 plus 1. And this is 1 plus 1 half. Let's we solve it. So 1 over 3. This is 1 plus 1 is 2. And this is what? 2, 1 and half means 3 over 2. Okay. Am I correct, guys? Now,
Yes,
2 will cancel 2, 3 will cancel 3. Okay. Now, what is the result? This is 1. What we are getting here? 1. Okay. Now, you can see this is true. Pn statement, Pn is true for n equals to 1. Okay. Again, pay attention here. This is first of all, whatever statement is written, you have to write that as a Pn. What? That is as a Pn. Write Pn and then write the statement here. This is the statement, okay? Or you can say question. Now this statement we have to true for 1. Okay? We have to make it true for n equals to 1. So you can see in this one we have taken n equals to 1. So when I take n equals to 1, it means I will take only the first value. This is n equals to 1. Here also n equals to 1. This value I'm taking from here. Correct? And now here in the, you can see n equals to 1. I'm writing here n equals to 1 here, n equals to 1 here. Now I simplify this one, then I get 1. So 1 equals to 1. It means this statement Pn is true for n equals to 1. First step is clear?
Yes, sir.
Okay, now you have to take this statement for n equals to k. Okay. Now let any statement, let Pn is true. Let us we assume, okay? Let us we assume let us we assume Pn is true for n equals to. Okay, let us we assume Pn is true for n equals to k also. Okay, so in that case, what I will, on the place of n, I will write k. So look here, this is k. On the place of n, I am writing k. So pk says that or equals to square of 1 plus square of 2 and plus square of k. Look here, 1, 2, and then n on the place of n, I'm writing k. So what I will do here, wherever there is n, I will write what? K. Okay, this is 1 over 3 k. This is k plus 1, and this is k and half. Is it okay? Am I correct?
Yes, sir.
Understanding how do I get this result?
Yes, sir.
Okay, Riva, you also understood how does I get this result? Here, look here, wherever there is n, I'm writing k. This result n, this is k, this is n, this is k. This way I get this result.
Yes.
Okay, so this is very important result. This result we will use. This result we will use to prove another statement. So this is a question one. Okay, I will go down. Now after this pk, you have to take one more term k plus 1. Okay, now k plus 1. After k, we will take one more term k plus 1. So how will you write this? You will write this is square of 1 plus square of 2 plus already square of k, and then one more term k plus 1. One more term we are understanding this one. Is it okay?
Yes, sir.
Yeah. So for this one, if we look the sum of this, look, this sum of this, for this sum, we can use this result. We can use this result. Okay. This is the, so on the place of this one, on the place of this, I can write, I have to use this result. Okay. 1 over 3 k plus 1 and k and half. Okay. This is what result, understand again, please. This result I'm simply copying from here. This is I'm copying. This is from pk. This is the result of pk. Is it okay? Now what was the term? The last term k plus 1, its whole square, I'm writing. Is this clear, guys, everybody?
Yes, sir.
Now I will simplify this one. Can you tell me what is common in both? K plus 1
Okay.
and k plus 1 is common. This is k plus 1 here. It is k plus 1 whole square. So it means I can write k plus 1 common. Can I?
Yes, sir.
1 over 3, then k, and then k and half is left here, and then k plus 1 is here. Okay. Is this step clear? Guys, is this step clear? Okay.
Yes,
So now what I am
sir.
doing to make it simplify, 1 over 3 k, this I can write 2k plus 1 over 2. This I can write 2k plus 1 over 2 plus k plus 1. Now, wait a moment. I will simplify it more. Okay, so k plus 1 here, and this is k multiply 2k square, k into 2k square, k times 1 is k, 3 times 2 is 6, plus this k plus 1, okay, and this is k plus 1, 2k square plus k plus 6, okay, 6 will go here, 6k plus, directly you can multiply. You can write 6 into k, 6k plus 6 over 6, okay. Now 6 you can take outside, 1 over 6 k plus 1, and this we can write 2k square plus 7k plus 6. Okay, now this is a quadratic function. We can factorize this one. How can? Look, 2 times 6 is 12. So we can split this as a 4k and 3k. 4 plus 3, 7, 4, 3 is 12. So this is 1 over 6 k plus 1, and this is 2k square plus 4k plus 7k. I'm splitting in 4k and 3k plus 6. Now 1 over 6 k plus 1, and what is common here? 2k is common in this one. 2k, k is left plus 2. What is common here? 3. So k plus 2. Okay. So 1 over 6 k plus 1, and this is k plus 2, and this is 2k plus 3. Okay. Understanding this one? Now what we can do, answer, actually we have to bring answer in the form of 1 over 3. So after this one, guys,
Wait, so can you explain that part? How did you get 2k squared plus k over 6?
2k square.
The
Okay,
one on the
this
most
yeah,
top
yeah.
part.
Okay.
Above that.
Okay. See, 2k square, look here. K times 2k. K multiplying 2k, also multiplying with 1. So k times 2k is 2k square, and k times 1 is k. Now, k times 2 is 6. Okay, here 6 here. Now taking LCM 6, so it will be, 6 will be multiplied to 6 will come here and here. Multiply to this and this way. Is it okay? Now,
Yes.
after this one, what we have to do, our answer should be in this form. Which form? Look at the question, 1 over 3, and will be replaced by k plus 1. But there should be 1 over 3. So 1 over 3 means this we can write, what? 1 over 3 times 2, k plus 1, and k plus 2, and 2k plus 3. If you look at 1 over 3 and last step, there is 1 over. In last step should be 1 over 2, like this. Okay. So what we can do here, last step we can split, because answer should be in the form of, this last step. Okay, this last 3, this 3 I can write as the show you. This 3 I can okay, wait, this one 3 was there. This, yeah, here 3 is right here, but here I will split this 3. I will split this 3. 2 plus 1. Why 2 plus 1? Also why I'm writing this 3. 2 plus 1. Now look here. This is 1 over 3. K plus 1. K plus 2 means this is okay. Understand? This you can write 2k and plus 1 over 2. This 2 I'm shifting here. Okay, this 2 I have written here. So, 2 will cancel this 2. 1 over 3. K plus 1. K plus 2. And this 2 will cancel this K plus 1 and 1 over 2. Now, what is this important? Why I'm writing this K plus 1, K plus 1? If we look at the question, this statement is true. Okay, it means we are getting this form. If we replace n equals to K plus 1, we are getting, yes, n, K plus 1 is here. You can see here. This K plus 1 on the place of n, if you look, K, this is n. N plus 1. So K plus 2 means K plus 1 plus 1. So we are getting, okay. If you want to write this K plus 1 plus 1, you can also write. And next is what? N plus 1 over 2. So this is K plus 1. Okay, n means K plus 1 means n equals to K plus n. This is 1 over. So we are getting the this one. Okay, this form. So it means what we write, at last we write, this was the, actually this was Pk plus 1. So Pn is also true for n equals to K plus 1. Okay, n equals to K plus 1. And one more thing, in the beginning, you would be able to know answer, what answer you have to bring. I will tell you. Suppose I'm going to scroll down it. Okay. For example, this is a question. Okay, you hence prove now, hence prove. The question has been proved. Now what? But for it's for to make you understand one more thing I want to discuss with you. For example, see, we have, this is the statement. You know, I would be able to know what will be my final answer in the beginning. You will be surprised. Without solving, sir is saying, I would be able to know what should be the final answer. But this is the beauty of this induction method. We have to prove this n equals to K plus 1. Okay, Sona. So my answer should be,
Yes, sir.
my answer should be square of 1 plus square of 2 plus square of 3 plus obviously K square. Then there will be K plus 1, one more term. It should be wherever there is n, I will replace n by K plus 1. Okay. So it is 1 by 3. Then n means K plus 1. Then n is again here, K plus 1 and plus 1. Again, n is here, K plus 1 and half. So this should be my answer. This step I can write K plus 2. This step I can write K plus 2. But now I know the future. I know what should be my answer. This is my answer. And if you look, after doing so much calculation, I'm reaching at this step. And here, in second line, I'm using this figure. But in the induction method means there is a particular pattern. First, you have to take n equals to 1. Then you have to take n equals to k, and then k plus 1. This you have to show step by step. Here it is a shortcut way. I'm showing what will be your result, so that you may know when you are solving what answer and in what form you should bring answer. Okay.
Okay, sir. So can you scroll up
Ah.
to the simplifying part? Because
Yeah.
I'm kind of confused in one of them.
Go,
A
taking
bit
up,
down, sir.
down. Wait. Actually,
No, in the simplifying part, sir.
going up. Where you make me stop there? You can stop me there.
That one, sir. The after the factorization.
Okay, after the factorization. This is factorization. You mean this part? 7 is split it into 4 and 3, right? Is this part?
Oh, wait, sir. Let me see first. After that one, sir, the 2k bracket k plus 2 plus 3. Can you explain from there? How did you get that?
Okay. This you mean you which okay I will this
From from that
this
one, sir.
this or up or down from here? From here?
From that one, sir.
Okay. Look, this 6 I split into 3 times 2. Why I'm doing 3 times 2? Because I know my answers should be 1 over 3 and okay. So 2 is there, so I will remove 2 from here. Rest of things are same. K plus 1 here, k plus 2. Yes, if you wish, you can write k plus 1 here, and then this 2k and 3 I am writing 2 plus 1. Why I'm writing 2 plus 1? Because I know in the last I have to bring 1 over 2. So that's why this is 2 and 2 plus 1. Okay. Now this 1 over 3, k plus 1 here, k plus 2 here, this times 2 I'm writing at the last. Okay, meaning is the same. It is still same 3 times 2, but now I'm writing this in the denominator of the last term. And here 2k plus 2, here I'm taking 2 common. When I take 2 common, so k plus 1 and plus 1 here. Okay, I'm taking this or understanding this one, I'm taking common from this.
Oh, yes, sir.
Right, so now it becomes plus 1 and this plus 1 here. Now I'm separating this one. I'm separating this one. 1 over 3, k plus 1, k plus 2. I'm separating this over 2 plus 1 over 2. 1 over 2 is here. And when I write 2k plus 1 over 2, 2 and 2 cancel each other. So k plus 1 is left here. Understood this step?
Okay, yes, sir.
Wait, and I think little bit confusion, right? I will write here, no problem. This 2k plus 1 and plus 1 over 2 means 2k plus 1 over 2 and plus 1 over 2. This 2 and 2 cancel. Now k plus 1 and half is left. This is k plus 1 and half. Okay.
Okay, sir. Can you just scroll up a bit so I can take a picture?
Okay. From the beginning.
No, sir. Just from the k plus 1.
Okay. Okay, starting.
Okay, thank you.